All right. Hello, everybody. We're live. I think we're getting ready to go. I hope everyone's doing well. We have a very special session today. We're actually bringing back Hamza for a second round of ZenML. For anybody who missed the first one, I'll actually share that now in the chat on the MLOps channel. We've had Hamza here before, software engineer turned ML master. He has built an incredible open source community and open source project called ZenML. We got to see a really cool introduction to it when it was just a baby, but there have been so many changes and so many updates and such an incredible new set of integrations that we really wanted to have Hamza back, both to show us what the new ZenML looks like, but also to kind of give us some mind sharing on how he actually scaled up his team and was able to re-architect a full open source project from scratch without kind of breaking everybody's original flow. So that little introduction, Hamza, welcome to the show. Thanks for coming back.
Yeah, thank you so much, Ben, for inviting me back on. It was like really fun last time, and it was early days, and now we're about half a year or more like down the road. So yeah, lots of things to share. Lots of exciting things happened.
Yeah. So what are some of the big things you're teasing that we'll kind of get to look at today?
Well, we essentially what happened last time is we were just sort of beginning, right? So like with ZenML, the idea and the vision is still the same, but we along the way initially we took some shortcuts in terms of architecture, which you might understand, just to get things out there and early feedback, and so on. But then the technical debt like bubble got us to a point where we were just too slow, and we had to really stop, pause, take a 2 month sort of break from features, and like re-architect the entire ZenML architecture. And then also, of course, in that time, we have built a lot more integrations and have built the tool out, and it's a lot more mature now.
That's really, really cool. And before we jump into that, because I want to leave time for you to go through everything, how were you kind of able to corral your full team into doing this full re-architecture to stop features to kind of start from scratch?
Yeah, so I mean, I put up the picture there, so that's a bit of the team. It's not all of it, but through a lot of sailing, I guess, is the way to do it. So like we had to take a lot of breaks, but honestly, it wasn't so easy. When you're building an open source product, I mean, I guess it's the same if you're building any product and you go through such a big change, and you have to deliver features on one side and keep everything up to date so that you have the growth. But on the other side, you need to re-architect it without people knowing what's happening. So really, I think we're very lucky to have very talented engineers on the team who took a lot of time drawing things out and sketching things and brainstorming and really making sure we had the milestones set first, the tests written out, everything sort of laid out in terms of the roadmap, and then like diving into it and not looking back, sort of. And when we did that final merge, it was like 30,000, 40,000 lines of code, and we were like, "Wow, how is this working? It doesn't make any sense."
It's an incredible feat. Yeah, I have. If any engineers are out there, I'm sure they're listening and scared by the idea of a 30,000 liner file merge. But it's an incredible feat. I've been playing with the new version, and it's really, really cool. It's super easy to use. So I'm going to jump off. I'm going to let you take it away, and I'll jump back in if anybody has questions.
Fantastic. Thank you, Ben. Yeah, I mean, I thought because we do have the 1 hour video last time where we showed ZenML in its early days, I thought I would still, however, take the time for those of us who are watching this or understanding about ZenML for the first time to just briefly first go through the basics, and like talk a bit about the 0.20.0 launch. But even before that, what ZenML is about. So like this is the team behind ZenML, where we're like spread out all across the world, different backgrounds, different disciplines. And we built ZenML because we sort of scratched our own itch while deploying multiple machine learning models. And one of the biggest problems we had was there were so many tooling opportunities out there to use fantastic tools, and you've had so many of those on, and everybody knows the vendors in the community. But there was not really good guidance, except for some educational resources in terms of how to put these things together in production. So with ZenML, what the ultimate goal of ZenML is to build a modular, standardized system that brings together the best of open source MLOps tools and gives it sort of a platform-like feel in terms of being end-to-end, robust, and production ready, so that people can build on top of it. It can be flexible, but also standardized and easy to use. So that's really the story of ZenML and how we got into it. Essentially, the real problem that it solves, the tool solves, is that you have these different personas, right, in ML in production. And we've talked about this a lot, about what these roles should be and who these people are. But essentially, in all the different stages of putting machine learning to production, it's still quite broken. What you know, like the entire process can be quite frictionful, and you don't really know what every stakeholder has to do in terms of responsibility. But also, to be honest, oftentimes they have different background and different knowledge and different opinions on these things. So the challenge really is, how do we get to like a unified interface that spans across different personas, different educational backgrounds, different experience, um, and still gives us that single source of truth that everybody can rely on. And this standardization for us at the very start was always about pipelines. So like ZenML is in itself, it's a extensible open source framework to create unified interface for MLOps pipelines. And what that means is it sort of treats pipelines as the standardization layer, but then also adds some more nuance to it and gives it more understanding of the MLOps concepts, so that you can plug and play different components of it as you build out your pipeline. And also inversely, so that you can even make it agnostic. So you can make the pipeline agnostic to the tooling or the infrastructure that is running behind it. So like just a small visualization of what a pipeline looks like. I mean, for those of you who have used pipelining tools before, this is quite standard. So um, it's just Python functions with decorators. So it's quite an easy standardized language, and you can put your Python code in there. And then that defines the workflow. And then how and where and in which infrastructure and tooling the pipeline actually runs is what is defined in a stack. So a stack has many different components, like an orchestrator or an experiment tracker or a model deployer. And it basically allows you to define these things outside of the paradigm of the code itself. So it separates the infrastructure configuration from the pipeline. And combining those two things together essentially gives you a ZenML pipeline run, which is a very simple concept, but can go a long way towards alleviating that friction that I spoke about in the first part of this presentation. Any thoughts so far, Ben?
No, I think this is great. Keep it going.
Awesome. So that's really, that was a 101 on ZenML for those of you who don't know where we're even coming from, right? Um, but I think the main reason you want to have me back on was really to talk about the 0.20 release. So this was the release where we went from a huge architectural change that we were working for 2-3 months internally, and we released it with 0.20.0. And it takes us well towards the path of 1.0 maturity, which is also something which is going to be the next milestone. So what did we really do in this release? So first of all, the architectural change was essentially going from a very client-driven tooling architecture to a more traditional client-server architecture. Before, ZenML used to be pip install ZenML. You used to install ZenML. I'm going to simplify it a bit. So you install ZenML as a pip package, and ZenML interacted with your local libraries in that sort of environment, and used other tooling to like create these pipelines and stacks and run them. However, of course, when we talk to even slightly more mature organizations, that's not how they work, right? So they usually want to go through a central interface, and they can't necessarily give the client complete and absolute privilege of what exactly, like in order to run a pipeline which might be running on a production workload. So we knew from the start that in order to get the ideas out there and the abstractions that ZenML really is building out there, we needed to start from a client-based architecture, but we had to transition to a server-based architecture very soon. And this is what we did. So we put the server in the center, and with the server, we also were able to then introduce, as it's a standardized API, we were able to introduce the front end, which was also a very big milestone for us to have a visual understanding of what ZenML is doing, which goes a long way, of course, as you know, to explain what a tool is and what it does. While CLI and Jupyter notebooks are always cool, a dashboard gives it a bit of a fresh spin. All right, so that was the architectural change. We will talk about that a bit deeper here. So just, I mean, this is not so important to understand in a deep way, but really, it is just to illustrate what happens if you have a client-based architecture in general. So in general, if you have a client-based architecture, you needed to create a database, and if you had two clients or two machines or two data scientists, let's say, they had this internal YAML DB that we kept, and then we had this external database, and we had to keep those things in sync. And that actually is very painful, at a technical level, which is not so interesting, but it did slow us down. And of course, it added this complexity of giving permissions to these individual clients, which they might not have. So what you really want to do is you want to have the client not want to have any intrusive infrastructure, permissions or authentication at all, but go through a central server which is a server that you can control and can put into an infrastructure that is isolated and more safe behind a firewall, so to speak. And then you can put the database behind that. I mean, this is obviously very, um, like standard engineering wise things. Like this is what one might think you might start with, but given the legacy of where we came from, actually it was a very tough challenge to disentangle these things once we had started on that journey of just being client specific. So we had to introduce a whole layer of schemas and models and database stuff which just didn't exist before in that way. Right, and then this is what it sort of resulted in, a pipeline, like a dashboard, which is a beautiful new look. We're very proud of this. We built that on the side as well, in JavaScript and React. So we had these two, different functions forming in the company. And I mean, it's not just pipelines. So this screenshot, of course, shows pipelines, but also stacks and stacks components. So these two things, of course, are the essence of ZenML. And this dashboard will be a lot more improved in the next weeks and months. So you should really keep an eye out, because I feel like this will be the entry point from now on of ZenML, and we'll see that in action today. So once you have a dashboard, you have to expose it to the users. The way we decided to do that was to bundle the JavaScript files, into the Python pip package. So you were able to launch them straight from the Python package itself. So you just need to do ZenML up, and it deploys a server and, a web server and a web application, and you're able to log in and see it even locally. So everything is still open source. So that's obviously a huge part of ZenML, is that it has to be open source, given we are building sort of the standardization interfaces. If you're attempting something of that nature, you need to open source it. You can't just keep it behind closed doors and just, have a committee. So we also had, some discussion about this, but I mean, at the end, we also want everything in ZenML to be available to the public. So we also open source this, so it lives in a sister repository that I've linked here. If you can give it a star, of course, that would help, for those of you who are watching as well later on YouTube. It always helps to get a star in open source, but yeah, it is open source, and we're very proud of that. So that's the dashboard. Once we have the dashboard, like ZenML was very loved in our community for being simple, right? So that was the whole point, to make things simple, to abstract away complexity. And we wanted to maintain that. So now that we had a server, a service that had to be deployed maybe on Kubernetes, we still didn't want to lose this simplicity, and this making people think that, oh, now I need to involve infrastructure and it's going to be so hard. So like if you've been following our journey, you know that we've tried to make things as one click as possible for entry point, to sort of remove entry point barriers. Because I feel like, of course, if you're an advanced engineer, and there's a lot of people listening who are, it's very easy for you to deploy a Helm chart or use Terraform or to use GitOps to achieve these things, to deploy a simple service. But for people, a lot of the times people stumble on ZenML who are maybe not of that background, and we still wanted to give them a way to get to the cloud quickly. So we implemented a simple design, ZenML deploy, and with ZenML deploy, it asks you a few questions and it deploys it on the cloud for you. And that was very important to us. And we have seen some success with this. Of course, we also plan to put it on Heroku or on AWS Marketplace or something to make it even from the browser deployable. And we have the Alpha Cloud. So we have ZenML Cloud Alpha, which is available for pre-release or alpha release right now. So if you go to zenml.io, you'll see instructions how to get a free ZenML server from us as we release the alpha version. Yeah, so we wanted this to be frictionless. Right, and then of course, if you have a server, then you have collaboration like never before. So now we had these stacks which were talking to all these different pieces like MLflow and Qflow and S3 and Kserve, and we had these local versions of these things as well, and we had them distributed across different clients, and people obviously used NML like that before, but really it was very I would say like rudimentary, like putting YAML files in Git repositories and all that. And now everything is just goes through the central service, um, which allows you, of course, to add permissions and things that we couldn't control before. So we added this notion of sharing stacks. So let's say I have a Qflow cluster that I don't want people to access, and I want a certain stack like an MLflow production deployment not to be accessible to half of the, like some team, and some team needs access to it. So we added sharing of a stack as a first-class citizen. So just by typing ZenML stack share, you can share an entire stack now, uh, which didn't used to be the case before. And of course, it goes a long way into also IAM and permission management, which is something that we hope to implement as well. And just a few small details. So we used to have a lot of way of configuring these pipelines and these stacks, and now we just put it all into one unified intermediate representation. It's a beautiful little thing, which nobody ever appreciates because it's all hidden behind a little decorator. But like shout out to the team who implemented it, especially to Michael, who really took his time to understand the different ways of configuring pipelines. You know, pipelines are very complex, to be honest, uh, in their state. So you know, you have to understand what is runtime and when it's instantiated and when it's after it's deployed, the life cycle of it, and to put it all behind a neat little curtain to allow people to tweak it is no mean feat. And of course, we took a lot of inspiration from other tools, but we also had to come up with our own language for that. And yeah, that's it. I'm a lot of talking, of course, a lot of things that you might not have completely caught on, but I'd like to just jump into the notebook and show you this in action. So let's click on this. So we have this open source repository called ZenML-Gitflow. So it's github.com ZenML-io, ZenML-Gitflow. And this actually showcases a few things that I wanted to show you today, specifically around collaboration and what centralized stack sharing could give you. And that's really all I'm going to focus on. I'm not going to delve into other details. You can, of course, go to ZenML. It's open source. We have lots of resources on it, and do it yourself. But for now, we're just going to go through these. So in order to do this, I'm sort of in the essence of time. I'm going to go through a few notebooks and then a GitHub workflow that is used often in production with ZenML, because like last time, I think we couldn't really get to this production part of MLOps, right? We just still were in notebooks, and I wanted to go out of it today and show you how separating the stack from the pipeline and having portable orchestration can be enormously beneficial to you as you build your pipelines. I am, however, going to start with notebooks. That's always good. So just clone this repository, do a git pull, do a pip install requirements.txt, and run the Jupyter Notebook command, and let's get into it. So I have 3 notebooks. By the way, uh, apart from these notebooks, these are sort of minor modified versions of ZenBytes. ZenBytes is our course on MLOps and ZenML, which is open source as well, and it has a lot more lessons than just the ones that I'm going to show for those who are interested. Maybe Ben, if you can pop that in the chat. Right. So what is this notebook doing? The first one, well, it's quite easy. It's installing ZenML and some integrations, and we're going to just build our first pipeline. So I know that for those of you who know about ZenML, this is going to be a bit boring, but for those of you who haven't, I'm just going to show you a quick way of how to define a pipeline and start locally, because that's how everyone wants it. Nobody wants to set up infrastructure on the first day. And so you can see the notebook well, Ben, right?
Yeah, I think we could see it pretty well. If you could zoom in maybe a little bit more, that'd be great. But yeah, that's perfect.
All right.
Yeah, right there.
All right, so I'm going to define a very simple function and going to make it an exemplary flow of how someone might start from a script. So iris dataset, very simple flower dataset. Going to split it up into train test, going to train an SVC on it, fit it, score it, and print the accuracy. That's like literally 4 or 5 lines of code. It gets a lot more complicated in production, but essentially that's it. And I'm going to take all of those individual things and try to understand how to put them in steps in a pipeline. So for those of you who are thinking of pipelines for the first time, you have to think of pipeline steps or workflows or DAGs or however you want to call them. You want to think of these individual units of work to be not just constrained to your environment, to your machine. And that's really the paradigm shift that you need. You can think of these as Docker images. You can think of these as services running in a Kubernetes pod. You can think of these as a lot more than just code running on your machine. And that's really that rigor of thinking that way really goes a long way in developing MLOps really cool code. So here, for example, the only difference we did was we typed what the input of this function is, and we returned exactly that. And we decorated it with a ZenML step. So that's very simple. It's really, you can do this in a few seconds. We also did this with a trainer. We also did this with an evaluator. And once we do that, once we have those steps, we can also create now a separate function, a pipeline function, we call it. And in that pipeline function, you can import the data. Like you can plug this as a Keras model. So you can say, okay, the importer returns these 4 things, the trainer returns a model, that goes into the evaluator, and that's it. So you run that, and then you can instantiate a run of that pipeline by doing p.run. So you can see what happened here. Logs showed up. So importer has started, trainer has started, the evaluator started, it printed it out, and it actually printed out where the run is. So if I go to my brand new shiny dashboard, which is running locally, by the way, I can actually click on this and see a visualization finally of this pipeline. And this is all local, so you can see everything that flows between it. So last time we talked about caching and all those things. I won't repeat them, but we have everything materialized in a central artifact store. And you can see where it is, and you can play around with this. By the way, this visualization will get a lot better very soon. But for now, I think it suffices to show how the pipeline runs. You can, like, how did I do that, by the way, was a bit I skipped past that because it was already running, but it's just through ZenML down and ZenML up. So ZenML down spins the server down, so this local dashboard, and ZenML up actually spins it back up, just like the GIF we saw before. So you can see that I'm doing ZenML up now, and um, it's going to run a server again, and now this is available. So ZenML down switches it down, ZenML up makes it go back up. And this is all, by the way, local, so we don't need to do a lot more. All right, that's chapter 1, 5 minutes, that's quick. I'm gonna quickly go back to artifact lineage and chapter 2. So chapter 2 is very similar, and it's the same pipeline. And the only difference is that we're going to, well, first we're going to run this again. And honestly, the only difference in this chapter is we wanted to show you what caching is. So if you go back to the dashboard, you can see there's another pipeline run that I just ran. So you can verify that by seeing the name of the pipeline run, 644083, 644083. Click on that, and you can see that here it says that it's cached. So what happened was that ZenML understood that this pipeline on this particular stack, which is default, has run before. So there is no need to rerun those things. And this is going to get really interesting when you run on larger data sets, and you can shelve away your pre-processing and go straight to the training. And ZenML is quite smart about detecting changes in these pipelines. Also, it detects it when you change the code and stuff. So this sort of lineage of how a pipeline runs is very important because it's a data-driven process that you can see where your data lives. Of course, all of this is still local. So let's go to chapter 2.1. I'm skipping through these very quickly because they're very easy, and we already saw a lot of them in the first part. And here is actually like one thing I haven't shown you is we've seen a lot of these pipelines, but we haven't seen the stack, right? So I told you there are two parts to a ZenML pipeline. It's the pipeline run and it's the stack. So if I click on stacks here, you'll see that I have a few stacks set up. Here's my default stack. And there are two things which are important in here. So the important thing is the artifact store and the orchestrator. And I'll just pause a second and talk about these two in ZenML terms. An artifact store basically defines where your data is persisted. So once you returned your data frame here, or your model, where is that persisted? Like, where is that materialized? Is this materialized in a S3 bucket somewhere? Is it materialized in a local path somewhere? And that's really what the artifact store defines. And the second thing that's important is the orchestrator. And in the orchestrator, what's important is, okay, how is it running? Is it running locally on your Python virtual env? Okay, then it's the default orchestrator, but it could, of course, run on a Kubernetes cluster on AWS. It could also run on Kubeflow. It could run on Airflow. It could run wherever you wanted, right? We have these standard orchestrators. So you could port this pipeline away because you haven't baked in any knowledge of that tool into your pipeline. Similarly, another thing which is very important in these stacks is the third component, which is the subject of chapter 2.1, experiment tracking. And you can see that I've reused my two default ones in this default with ML flow stack, but I've actually added my ML flow tracker. And the way I did that is by running a simple CLI command, ZenML experiment tracker register ML flow tracker. It's already registered it, so it'll give me an error if I do it, but I can do, for example, this again. And after that, it actually registers a stack with a unique name and with all the components. So think of a stack as sort of Lego pieces, right? So you have a Lego piece, which is like a L-shaped experiment tracker. You have a U-shaped orchestrator, and you have to put it together. And ZenML knows how to do that, but you need to give color to that Lego piece, and you need to tell exactly if it's a yellow piece or a red piece. So it's what flavor is it? Is it ML flow, or do you want to put weights and biases and Selden together? Do you want to put Kubeflow and ML flow together? you need to tell that story to ZenML so it can help you. So in this particular case, the story I'm telling is, hey, I want MLflow to track my pipeline experiments, and I want to run locally and track all my artifacts locally, right? And let's give this a fun little name, Lego story, blah, 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 whatever. And now if I run this, you'll see something really interesting happening. First of all, it'll register the experiment tracker. And secondly, it'll register the stack. And if I go back to my dashboard, very quickly, you can see the Lego story stack is there. Indeed, it has these three puzzle pieces with the new ML4 tracker. And by the way, you can see everything which ran through it. So it's really simple to use with finally a visual interface, which somehow was harder before. Um, all right, so now that we have the stack defined, uh, if I'm going too fast, Ben, do jump in with questions. I don't mind. We have some time, but I'm going to keep going until then. Right. So now that we have an experiment tracker, how do we use it? So the way we use it is just like you would use any experiment tracker. So with MLflow, they have this really handy auto log function. Like shout out to MLflow, by the way, with their 2.0 release. Really exciting news. Um, and we'll have support for that as well soon. With MLflow, they have this autolog function where if you put that in a function, it captures everything around it essentially. If you train a model or whatever, it captures everything. So I'm using this as a shortcut, but you can also log individual parameters. You can log an image, whatever you wanted here. And you can see using some Python gymnastics, I am actually looping over. I'm doing a form of hyperparameter tuning, and I'm actually creating many pipeline runs with different gamma hyperparameters. Um, and I'm going to run that now. So I'm going to go through some hyperparameters. It's the same code basically. And I'm going to tune my SVC. And you can see that the cool thing about this is that I did not need to set up MLflow with ZenML, right? So all I did was at the top of my step, I said, hey, use this experiment tracker with the name MLflow underscore tracker. This name should be the same as what you see here, MLflow underscore tracker, right? So that name is important, but you didn't need to put any other knowledge of MLflow in the step itself except the actual logging. So you can actually change that. You can say it's a production MLflow tracker. It's maybe a staging one. So the configuration of MLflow is abstracted away in the stack itself. And when I ran through these, what ended up happening is a lot of pipelines ran. And if I slowly go through them, there's a couple of handy functions that ZenML provides you to actually open up the MLflow interface. Now, what's important to know is that MLflow follows the same philosophy as ZenML in so that it can run locally and it can run in the cloud. Um, and like, by the way, I think I assumed that people knew what MLflow was, but given that it's one of the most popular tools out there, I will spare the audience the understanding of what it is. But this is how it looks like. So you can see that I ran these pipelines. ZenML set up everything around MLflow that you need to know itself. So it set up the what's called an experiment in MLflow. It set up the runs, and actually, interestingly, the name of the runs match the pipeline name, the pipeline run name. And you can literally go now and see what an individual uh, pipeline has. So it has many parameters. You can see the one that we tuned was called gamma. So you can find it maybe around. Actually, a better way of doing this is to just to compare the ones that we just ran. So of course, MLflow, one of the best experiment tracking tools, lets you do this. So you can see, for example, as the hyperparameter changes, the accuracy changes accordingly with the F1 score. So you can, of course, go around and do hyperparameter tuning stuff. So your pipelines become sort of like experiments with this integration. And it was very simple to do. You didn't really need to deploy MLflow. You didn't need to do any infrastructure setup. You just could go. Cool. So that's what it is. There's another little experiment here with weights and biases, which is another amazing tool, but I'm going to skip that. And I'm going to go over to what I think is the cool part of this demo, which is how do you get to the cloud, right? So now you have really you have really a local setup now, right? You have local ML flow, you have local experiments, you're running them, cool. But how do you end up really going transitioning from that local setup to a cloud setup? How is that even possible? Well, of course, the answer is stacks, right? And here you're gonna have to bear with me. I'm gonna have to explain some concepts before we go on. So, right, you have your pipeline and you have your stacks, right? The pipeline can import, analyze, train, validate, blah, 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 deploy even. Um, and it has these multiple stages it goes through. It goes through a local pipeline development phase, what we just saw in a notebook potentially. Then it goes to a staging stage, like no pun intended, which actually maybe is something which initially runs on the cloud with maybe test data. I'm just making this up, it could be anything. And then finally it goes to production, right? Where you maybe do a deployment at the end, or you put it in a model registry or something, or do some promotions. Lots of little fun details that we've talked about in this podcast for with many guests. So how does ZenML facilitate that? Well, the way it does that is it starts you from this local stack, right? This local pipeline. And this local pipeline is reading local data. So maybe it's a CSV file that's local to you, and it's still using your local stack. And then in this demo, what I've done is I've set up a ZenML server, which is running centrally somewhere in the cloud. So that's something that you can do with ZenML deploy, or you can get your ops people to do it. And whoever does the deploy can also set up a staging stack. So in that stack, rather than configuring, rather than configuring the local orchestrator or the local ML flow or the local artifact store, what we're doing here is we're saying, don't run this pipeline locally. Run this on our staging environment and read from staging data, right? So like the data can be also read from a Google bucket or something, or maybe like a database or Snowflake or whatever. And then finally, for production, um, like this could happen, for example, when you make a pull request. So when you make a pull request on GitHub with some changes, some people could review that change. So let's say you change some training code, and while you're reviewing, GitHub action triggers, which actually runs the same pipeline on the staging stack and tells you whether it actually ran through what you wrote, right? Testing, integration testing in a way. And then when you merge to main, what happens is then it actually also deploys. So it reads production data, it trains the model, tracks everything in production ML flow, and it deploys it on something like Kserve. I'm not going to go into the details of how ZenML integrates with Kserve and Kubeflow to make that happen, but it's very easy, right? So it's just importing some things and putting steps into a pipeline. And that's really what we're going to do today. Um, let's really go to the code and see how we can set that up. So this is the same repository, the Git flow repository. And I ran these notebooks, but I've also put all the steps and all the pipelines in these utility functions, or well, in separate scripts, I meant. And you can see that all my functions are now here. So I have a development data loader, staging data loader, and a production data loader. All of these are reading from different environments. The code is still there, right? And I have these stacks, and these stacks are actually a bit more complicated. So I've set them up front, and you only have to do this once. So I've set up my, in this case, what I've done is I've set up my staging stack to actually orchestrate on GCP. So we're doing cross cloud today, right? So we're doing a Vertex AI. Vertex is a GCP, like the GCP version of Kubeflow, or a GCP managed orchestration system is Vertex pipelines. We're going to orchestrate on GCP and Google Cloud on the staging stack. And then in the production stack, we're actually going to use the AWS Kubeflow and Kserve production stack. I've set those up. I've set up my stacks. That's something you're going to have to go through in any case. And I've deployed my ZenML server, which is available on demo.zenml.io. And you can see that I have my stack set up here. Let's briefly take a look at them. It has my experiment tracker, it has my orchestrator. I mean, I can take a look at them, right? So everything is here. There are some secrets like my tracking username and tracking password for MLflow. Secret management is managed by ZenML as well. And we have this AWS one, which I call Kubeflow Gitflow stack. And here you can see, I think the primary difference here is that this is being stored in an S3 bucket, right? So the thing that's visible. And in the previous one, it was actually being stored in a Google Cloud bucket. So it's the same code. You literally don't have to change the code at all. You just set your stack, right? And how does that work? So let's try it out, right? Why not? So we have these three pipelines: run local, run production, run staging. If I was to run the local one, I could do something like, yeah, I can just, I mean, this I did in a notebook, but I just wanted to show you how you can do that locally. So this is running locally. It's the same pipeline. It imports data, trains, and evaluates. So I can change a lot of things here as I want. And you can see maybe one of the most interesting parts is the step that actually trains the model. So maybe I do some, I don't know, I print something here. I say something like this, or something very crucial. And maybe I change a parameter here, like in runtime or something like this. And I want that reflected in staging. So maybe I make the same change here, let's say. So you can see that the difference between the local and the staging pipeline run is that it's using the same steps, so it's importing the same functions, but this one is using the development data loader, and this one is using the staging data loader. So let's actually, before we commit this, right? Let's make a new experiment. Experiment slash my fantastic model, right? So I switched to a new branch. This is simple Git, right? So what I want to commit is my trainer. I change something in my trainer, and I change something in my runner files. So, and I say, wow, what an awesome experiment. And I push these to my branch. That's all I need to do. I don't need to have everything set up. I don't need to know how this works. And then I can go to my browser, and you can see GitHub very usefully already gives me the pull request that I need. So I can tag whatever myself. Can I tag myself? No, I can't. But let's say I tagged another account that I have, and I can create the pull request. Now, the moment I create a pull request, excuse me, uh, that was on the other room. Never mind if you heard that. So the moment that I make another pull request, what is happening is, of course, I can do the normal GitHub behavior. I think a bit easier just to use the unified view here. So you can see that I made this change and I made this change. And now, I can sit back while GitHub action triggers this staging run, right? And what the staging run is going to do is it's actually going to set up everything for me that I need to actually run this infrastructure or the same pipeline that you saw. The only thing I did was swap out that first step. The other two steps are the same steps that I just did, right? And it's going to install everything. It's going to run a pipeline. And eventually what's going to happen is it's going to run this on Google, right? So we can open up Google. And actually, let's first go to the ZenML dashboard, right? So let's see what the ZenML dashboard would look like. So you can see that the ZenML dashboard doesn't, because it hasn't started yet, it hasn't started a pipeline run, but it will soon. It will actually deploy something called a staging, train, and deploy pipeline on the Vertex Gitflow stack that I just spoke about. And that's the stack that we saw before, right? And that's registered, that's centralized. If I were to click on any step, you would see that now, rather than storing on my local machine, it's actually storing on a Google Cloud bucket. So we have transitioned that quite easily. And then also you will see that because I have my ML flow stack, so within it, there's my ML flow stack here, right? So rather than registering my experiment locally, it will actually, I think I have this open. So it will actually register on a deployed staging ML flow. This is running on the cloud, right? It's you can imagine this in a company behind a firewall. And here I have all my experiments logged and trained here, right? So the same thing that you saw locally is now happening outside, but I don't need to know about this environment, right? I don't need to set it up. I don't need to get access to it at all. It's all going through a central code repository. And finally, um, the, what's happening is we're also running this on Google Cloud. So you have to switch over to the Vertex orchestrator piece, and you'll see a pipeline like this. I mean, this of course looks very similar to, let's see, like this. This looks very similar. Of course, all pipelining tools look similar, right? You can see the visualization of the DAG. But here, the difference, I think, is that you can see also details about your stack. And here you see the details about your run. So if you want to see your logs, you can see them here. But everything else is the same. So it's a very standardized way of doing it. So um, in a few seconds, I think we'll see a new run being made in staging. Is there a question, man? Go ahead.
Yeah, it's right about this. So it's good that you brought that actions page up. I'm curious when you're talking about the integration between ZenML and GitHub Actions, that test run, for example, that happened as a
Mhm.
part of that pull request. Was that something that ZenML created for you, or did you create like the GitHub workflow file to run this test?
So I created the GitHub workflow files, but those were very simple. So all the GitHub workflow files did, actually, that's a good reminder for me. We should probably go through what this GitHub workflow file did. Um, it authenticated things, so authenticated Docker and GCP and all those things. That's something you need to do. And now it's done, by the way. So briefly, maybe we can go back to here. You see there's another run happening, right? So it pulled the previous image. This is just for caching. But very importantly, it set the stack, right? So it did ZenML stack set, vertex git flow stack. And then it just did Python run staging.py. Hmm. I think we can actually look at the raw file rather than the output. So here's the actual workflow file that we're talking about. So these are the two lines that it did. It set the vertex git flow stack. So setting it means that you're telling the central ZenML instance up. There's actually another important part. First of all, it connected to ZenML, right? So first of all, locally from the client, you need to connect to the central ZenML server. So you need to say, okay, this is the ZenML server with a username and a password. Then you set the stack that you want to use. You have an option of 3 stacks. We use this one. And then it just ran the pipeline just like you would locally. So that's all you needed to do in that GitHub workflow. So it's a very simple one. And the advantage of that is that you can control your pipeline logic separately and do all the authentication inside GitHub Actions. So you don't need to have Kubeflow installed or Kserve installed to run these pipelines.
Okay, got it. That makes sense. Thanks.
Yeah. And you see what ZenML itself did in the background was that it figured out that, okay, this pipeline requires ML flow. It requires potentially Kserve. It requires all these other tools. It built the Docker image, pushed it to a central container registry. That container registry, by the way, was defined in the stack. So you can see, for example, there's another container component called container registry. So that's also defined. So all of this is modular, and then it just kicked off this run, which is happening right now. And you can see it's running right now as we speak on Google, right? So that's really the modularity, the power of having different stack, different, separated from the pipeline. So let's say you did that, right? You recorded your experiment in ML Flow. Let's see where that is, by the way. So the second step is running. Um, and everything is Dockerized, everything, the Git SHA is stamped with ZenML. ZenML tracks all that metadata for you for reproducibility, and it tracks it across the tools. So let's say you looked at your experiment on your staging ML flow and you said, that's pretty good. I mean, we got some nice parameters here. Okay, compared to the last run, maybe I can compare it to the last run, and I can see my accuracy or something, I don't know, whatever is relevant. And then I can say, okay, I'm happy with this change. Let's go back to my pull request and merge it. So I was a bit sneaky, Ben, when you asked a question, I actually already merged just to kick off the next workflow. So let's say my MLOps engineer approved, or my lead data scientist approved this pull request, and then I merged it. When I merge that, um, it will actually create another pull request, this one, and rather than saying run staging, it will run production pipeline. And here it does the same thing as we saw before. So it does exactly the same, except it does it on AWS, right? And all it does is it connects to ZenML, sets the stack as the Kubeflow Gitflow stack, right? Not the GCP one, and then runs the production.py pipeline, right? This pipeline, by the way, is a bit different. So not only is it reading production data, potentially from Snowflake or something, but it's also deploying the model at the end. So it's after evaluation, it goes to a trigger function. It sees if the accuracy or something is bigger than 95%. And then it goes to a K-serve model deployer, which is a built-in integration, built-in step with ZenML. And when you merge it to production, I'm going to switch over to my ZenML dashboard. I think that in a second we'll see a new pipeline. You can see in my can see this prod, train, and deploy. This is running right now. And the importer step is now writing to S3. It's running on the Kubeflow Gitflow stack. And that Kubeflow stack is visible in my Kubeflow AWS Kubeflow cluster. So this Kubeflow is deployed by ZenML. It's hosted by us. You can see that in the URL. And this is what the pipeline is running on. So if I refresh this, you will see that a new pipeline is running. It's the same pipeline as we ran on Vertex. And the only difference is it's going to read production data now. So not staging data, it's going to read production data. And it's going to train the model. And maybe we can go to a previous pipeline to see this. It's going to evaluate it and not just stop there like the Vertex one did, but actually run a continuous deployment for you. So ZenML is aware, if you go to the logs here, ZenML is aware that a service, a K-serve service was deployed in the previous pipeline. And now it simply updates, rather than creating a new one, it updates your K-serve deployment. So let's say this is your deployment that is running on a Kubernetes cluster, which is prod, right? Like it's serving the website traffic. And now I just literally, with one merge, without my data scientists really knowing about the infrastructure, all they had to do was write those 3 lines of code, make the pull request, and I could change my stack and I could take full control over everything else. I could add a data validation step here. I could add reports, Slack alerts here. I could add so many stuff here. And the data scientist doesn't need to run any of those, right? That's defined in your GitHub repository. And you're sort of orchestrating all these things with ZenML stacks. My staging run has run successfully. My pipeline is almost about to run as well. And we can see how that looks like here. So let me refresh this. Yeah, you can see it's almost at the end here as well. And yeah, I mean, at the end, what we'll end up doing is deploying a model that is serving live production traffic. So that's the flow. Lots more cool things you can do. I mean, like today was just about portable orchestration and getting to production. And in the future, what you can probably do is to clone this repository, right? Copy it over to your GitHub or whatever. Use the same action that I did. Replace a few secrets, set up the infrastructure. We have stack recipes that let you deploy Kubeflow and all those things with one command. Deploy ZenML. It might take you half a day, a few hours of work, or you can get a managed one from us. And then start working this way, and you'll see how the power and of how it grows in collaboration. Like you see your data scientists contributing steps. You see your, and we've seen this happen, right? So that's why I'm saying we've seen more stacks evolve. We've seen custom stack flavors. Like if you want to orchestrate a completely different way, we've seen that happen. It's all open source. It's all extensible. It's a really standardized framework. You can really do anything that you set your mind on in MLOps here. And that really is the goal of ZenML. And this architectural change that we talked about at the start made this possible. You can see now the staging is done, the prod is done, and we have a new and deployed model. Cool. Wow. Talked a lot, but I think we're almost at the hour now. So at the end, just give us a start on GitHub, join our Slack if you want to chat more about these sorts of things. Very passionate about MLOps, the entire community. We're almost 1,000 people now in the community, which is really crazy. Given the last time we talked was not even half of that. So yeah, very excited. And yeah, thank you so much for having me on again.
Yeah, this was fantastic. Thanks for coming back on. I don't think we have any live questions right now, but we only have a few minutes. So I'll just ask maybe to see, I asked this in the beginning, but now that we have a few more minutes to think about it, when you decided with your team that it was, you had enough tech debt, you had to restart, what was the planning process for that? Like, how did you all get in a room and come to consensus about this new architecture and kind of the execution plan?
Uh, we created a lot of design documents and we split up. So we sort of created squads first in the team, and then these squads came back into with design proposals. And maybe I can show you one if it's not confidential. I'll put it off screen while I pull it up. And these design proposals are really our holy grail for asynchronous communication. We are all over the map in terms of people, from Malaysia, India to Munich and Germany. And just to give you a flavor, maybe here's some of the things that we talked about, let's say integration and system testing. And we have this really detailed proposals like PRDs that we talk about, and then we comment and get to consensus async, and then we have synchronous meetings to discuss them. So yeah, it's a bit intense, but I feel like if I was to give any advice, um, do more of this than jump into things, because that's going to make you ultimately faster. And I think without this, we would never have been able to achieve consensus and execute.
Were you involved in every one of the design decisions, or were there spots
I,
where you just trusted that your engineers would be able to figure it out and make calls without you?
Honestly, I know nothing about how ZenML works right now. So I don't know how it works. I'm an engineer. So I used to know it, but now after the architecture, I think I've done really, um, I'm, I wasn't the bottleneck at all. We trust the engineers. They're way smarter than me, to be honest. And they implemented the most fantastic way forward. And yeah, I mean, of course, there were decisions that we made together as a team, but we had a very distributed sort of squad-based system. So squads had leaders, and they ultimately made decisions. So I didn't want to get in the way of that. That wouldn't have
Sure.
worked.
Awesome. Well, I think we're at time, but Hamza, this was fantastic. Thanks so much for sharing your wisdom and your product. I shared the links to everything, the example flows, your GitHub flows NML, ML flow, your last talk. So we have everything if anybody needs that stuff. But yeah, thanks so much. We really appreciate your time.
Cheers. Thank you so much for having me on.
All right. See you later.
Bye.